This is Team 2, Groovy, Never Glue, and this is our project design video with our completed project as well as its active operation. Over the course of a couple minutes, the project will collect water, accumulating it, and dropping it into the dish right there.
See how it shows that the temperature is increasing over time. The number at the top is the dew point, and the number at the bottom is what it says the temperature of the plate is. Once it gets to around like 12-ish, it should start condensing small amounts of water. So right here we have our small heat sink. This is what the water condenses on. And here is our large heat sink and fans. This is what dissipates the heat. And then in between them right here is what's called a Peltier module, which takes an electric current to move the heat from this side to this side very quickly, which allows it to cool very quickly and condense water. Down here we have our microcontroller setup, which outputs some information and it controls the power state of the fan and the Peltier module. So basically, it uses this sensor right here to detect what the air temperature and humidity is, and uses that to calculate what the dew point should be. And then with that calculated dew point, it goes through a process of hysteresis, clamping down the temperature to be in between the freezing point and the dew point. So when the temperature of this plate is detected to be higher than the dew point, it's turned on, but when it gets close to freezing, it turns off.
To demonstrate the use of this device to its highest power, we are using a humid and hot area. We chose the UREC swimming pool because if you've ever been here, it is extremely humid. When you walk through the doors, it's kind of like you hit a jungle. So we're trying to take the large amount of humidity in the air, and it'll probably, hopefully, be easier to condense water and get in that plate.
Okay, so in testing, we have ran into an issue. Our power supply has a built-in surge protector. When it's triggered, a backup capacitor temporarily supplies power in its place. When the Peltier plate module and fan turn off, the sudden drop in current causes the surge protector to trigger. This alone isn't an issue, however, it becomes problematic when considering the chatter from the plate sensor at temperature that is close to the dew point. And when this happens, the power switches off, which triggers the surge protector, which immediately depletes the backup capacitor and causes the device to lose power and reset. So we can get it to take moisture out of the air and condense, as you can see, but we do have to tweak it a little bit. And to fix this, we could modify our programming to include a hard-coded limit on how often the main relay can be triggered and switched on and off, which would mean that it would stay at a constant, the power wouldn't fluctuate and it wouldn't power off, which is good, which would mean we would have more condensation and more water.
Just because it takes a while to condense water.
That's true.
And
As you can see,
you have to
droplets
get
are
big
actively
droplets
forming.
to actually fall.
They will drop in a couple minutes at
We're
least.
just going to leave it on. And if it
This will be
resets again,
easily
we'll turn
seen
it
in the
back on.
time lapse.